This is a scientific approach for letting blind biological creatures on planet Earth see again. When an eye is blind, or the optic nerve is damaged, though the Collucilli Superior and LGNs are intact, a connecting link with the brains can be realized via those LGNs and those collucilli. Because of the fact the retina does pre-processing performance, like detection of movement and detection of main lines and forms of surfaces, a camera, to be placed in the eye socket, must also perform accordingly reasonably such pre-processings. Collucilli Superior's functionality is physical layout and the layout light sensitivity as copy of retina of corresponding eye. Its focus is also on black, white, signaling. Goal is to control eye, head, and body movements. The LGNs filter lines, shapes, surfaces, forms, colors. Goal is to determine where objects are, then what the meaning of each object is. For this reason, at first tests, it is logical to place a grid, for example 10,000 by 10,000 pins, on that collucilli, with on each pin, a, off, and on, signal push, so on each pin, a black, and white, signaling. And a grid, same grid format, on a LGN is logical to be putted, in which each pin produces 6 signals at different height of such a pin. XYZ, coordinates, location objects regarding eye position, view directions, lines, shapes, colors, info. It will take intense weeks to learn to cope with the new data, on, and from, those two LGNs, and on, and from, the two Collucilli Superior. The focus must be on movements, linings, surfaces, forms, shapes. Within few months color info can be trained. Both LGN and Collucilli lie deep in the middle of the brain. During the operation the entrance will be created medial just above the cerebellum. For lifting the brain locally the skull will be folded up. The 4 grids will be inserted towards the area in folded, rolled up, state. To get near CLG, and near, CS, a space creating form will be inflated. Old experiments already showed that the map of the light-sensitive layer in the eye is almost identical to the map of Collucilli Superior, but mirrored in 2 ways. The left eye is linked to the right Collucilli, where above and below, and where left and right are exchanged per each Collucilli. So when mounting the grid, please pay attention, puncturing the grid of the left camera into the right Collucilli, and right and left. With the CGLs it seems more unclear, and it is advisable, in the first experiments to perform the identical actions, as just mentioned with the 2 Collucilli. So cross-linking left and right. If the eye muscle nerves, including nervus oculomotorius and nervus ciliaris, are not damaged, those nerves can be connected to the camera. to place the biochemical, electrical, connection between a nerve and a camera direction motor. Every nerve needs a radial, charge-sensitive sensor. If ions are radially perpendicular to the nerve path, this must be measured. The speeds of these ions jumping across, and the amount of charge that crosses, is important information for controlling the direction of the camera. This is because both frequency and amplitude are crucial information. Some small hardware and software will be needed, but it must also be possible to adjust it later. The proposal is therefore to place a lot-in software, which comes close to the eye, a mini plug, to install new software, and to carry out several tests. It is also advisable to use the mini plug and the hardware for optimalizations and mutations of the camera and data filters. If the eye, muscle, nerves, including the nervus oculomotorius, are damaged, movement of the camera, in this operation, is not yet possible. Because then deep brain detection pins are needed, which must be located deep in the midbrain, among others in the cerebral aqueduct. This then also applies, in the event of damage, to focusing, and to the light incidence strength allowance, and to see far away and to see close up. Because this must also be done by means of a few deep brain detection pins, including anyway in the ciliaris ganglion, located in a very basic brain area, and possibly even close to the Edding-Westphalen nucleus. After the operation, it will take approximately 2 months to allow the client to learn how to handle the new data from the eyes properly and to respond to it. And then to train how each camera can be controlled. If you want to consult, and/or have questions, and/or tips, do not hesitate to contact horizontal-han, horizontal-vrog, at hetnet.nl. In English, the Han question, with horizontal dashes in between, at hetnet.nl.